to our next Fenceline monitoring presentation. Atmosfir optics. So Gilad Shpitzer, also from Atmosfir Optics. Gilad, let me introduce you. Okay.
Yeah, but still got time.
Oh, it's time now.
No?
Yeah. Okay. Gilad was born and raised in Jerusalem, probably tell by his accent. He graduated from Hebrew University of Jerusalem with a master's degree in atmospheric chemistry and environmental science. Has over 20 years of practical experience in the field of air pollution measurements, from source sampling, analytical laboratories to remote sensing. Welcome. Take a moment here while people walk in. We locked you out. Sorry about that. Okay, I'm going to start this introduction again since we got so many people locked out. I'm Stephen Lazar. I'm with Atmosfir Optics, and I'm your moderator for the Fenceline sessions for today. Next up, I feel pleased to introduce Gilad Shpitzer, who is the CEO of Atmosfir Optics. Gilad was born and raised in Jerusalem, graduated from Hebrew University in Jerusalem with a master's degree in atmospheric chemistry and environmental science. He's acquired over 20 years of practical experience in the field of air pollutant measurements, from source sampling, analytical laboratories to remote sensing. Gilad is the innovator, co-founder, and CEO of Atmosfir Optics and AS Research Services, international leaders in the field of atmospheric chemistry. Gilad served on the board committee of the Israeli Ecological Society, will be sharing some very interesting experience with us today. I'm going to pass around a sign-up sheet, and I would appreciate it if everybody here would sign up for this session. Even if you've been here for previous sessions, I just learned I'm supposed to do a separate sign-up sheet for each session. So if you start again, sign up again, that would be great.
Okay. I never knew all about me, so thank you for the introduction. So a little bit about myself and my background. So feel free to ask questions in the middle of the presentation, in the end. So I started as a source tester 20 years ago, pushing the probe, climbing the stairs, and run the biggest source testing group in Israel. Actually, we are the main contractor for the government of Israel. Maybe it's a good thing for the US. We do a lot of surprise check in the industry for the government measure. We use US EPA method from 1 to 322. We are just 425 accredited, and we're also part of the Source Evaluation Society and accredited. And actually, we were the first one. We also run an analytical laboratory from GC mass spec to HPLC ICPs, and we've got some unique features that you cannot find maybe even in the United States, like we are accredited for the aldehydes, silicas, and all those. But what we're going to talk about is a company named Atmosfir Optics. In 2009, we were the first one to go into refinery, and we start measuring. We did 1 week of measurement, and it took us around 1 month of 2 PhD to analyze the data. Said it's a good, but you cannot do a business. There are not too much PhD that know how to do the analysis. And then we wrote the method how to automate the analysis. So what we are not a manufacturer of equipment. We work with different manufacturer equipment. Some of them are here, some of them are in Germany, some of them all over the world. So we are agnostic. We are actually data and software research integration company. We provide defense and monitoring worldwide based on SaaS business model. Actually, I'm quite lucky. Some of my scientists actually wrote the method and invented the instrumentation back in the 90s. If you heard the name Robert Kagan, still working with SaaS. Until now, we are the only one that got ISO 17025 accreditation. measuring any gases in the atmosphere using US EPA method Tier 16. So we are the only company until now that got this accreditation. The other one is a government. Here you can see our accreditation, and because we have got quite a lot of patent, we can reduce the noise of the instrument and the atmosphere and give you very good detection limit. And now with one instrument, you can measure the BTEX and the aromatics and the rest of the alkanes, all with one instrument. So we heard a little bit about Rule 1180 that says that you need to integrate FTIR, UV DOS, but we can also integrate tunable light lasers for other reasons. Point monitors that starts from PIDs, electrochemical cells, and up to GC MALSPEC. We run the raw data through our software, enhance the quality assurance, and give you better, easy to understand results. We can do the whole installation or just give you the software. We do shorter project or fixed patent for the design. So I'm not ChatGPT, so I will not give you the very good answer for why we need the Fenceline monitoring, but in the end of my presentation, I will use it. And when we ask people where the emission coming from the petrochemical industry, so if you were in the 70s chart, you would say out of the chimneys because you saw a lot of chimneys with black smoke, but today we know actually most of the emissions go out of tanks, farm, product terminal, equipment trade, luminaires, cooling tower, evaporation pool, heat exchangers. And what's unique about all of those is that we are not measuring them 24/7. So if you got a problem, we can wait if it's in the LDAR program, and most of them are not, like water, and sometimes a year until we find it, unless we put some kind of a 24/7 monitoring. And I will convince you that the best way it will be to do Fenceline. So in other words, fugitive emission area sources are the major contributor to the amount of air pollution emitted from the chemical industry. Real-time Fenceline system are the appropriate monitoring technology to reduce the risk of the environment, the impact of the chemical industry, and the Philadelphia. So everybody heard about the Philadelphia refinery that was exploded. If you look at the data of the passive sorbent tube that was there, before the explosion, there were high concentration of benzene. Now imagine that we will have an analyzer that alert not just with benzene, but with total alkane that it's usually 100 times more than the benzene, and will alert. You've got high concentration, the high concentration coming from that area. So you fix the problem, and maybe you can eliminate the risk of explosion. So if this is our complex, so if you go with method 325, we're going to put a lot of point monitors around us or passive solvent. But where should we put it? If you go with method 325, you're going to do it with 15 degrees, 30 degrees, and 20 degrees, depends. What happens? The air pollution moves with the wind. So if there is emission going out, we will not sense nothing in point H, I, A, B, or G. And if we will sense it on point E, it will not represent our emission because it's give us higher results. So the actual result that will represent our emission, then will average our emission, will give, and it's good for the industry, maybe it's more representative because it will dilute the emission as line and it will give it more representative. So the concentration here can be 1,000 ppb, but in the average it could be 100 ppb. But the 100 ppb, it's more representative than the 1,000 because 1,000 is just 1 point. Open path measurement along Fenceline dramatically improves the ability to represent emission with measurement of the source. If we are measuring in chimneys, we've got our method, we've got our SEMS, If we go to measuring the city, we've got our ambient air monitors. But if you want to measure it on the fence line, the most appropriate, if the technology exists, is to do it with open path. Because equipment failure and human errors cannot be predicted in time or space, continuous 24/7 spatial monitoring system is required. We don't know where it's going to come, but where it's going to come. If you want to measure our annual emission, if we want to reduce our annual emission, is to find the problem faster and fix it. As a rule of thumb, if we will monitor our facility without adding extra money, we find the problem at day one that it starts, we can save 99 days until the elder come and find it. So every day equal for 1% reduction of emission. We don't build the huge scrubbers, we don't build the huge things. We just prioritize our elder job based on our fence line monitoring. So if you will have a fence line monitoring, try to correlate it with your elder project, and then you will have another thing. So the first program that will start dealing with fugitive emission was the elder program. And that says that you need to go and sniff every piece of equipment that you can reach and do it once a year, once a quarter, depends on the regulatory, and fix it in 2 weeks time. First, they start doing it with soap, and then they start doing it with sniffers. And then now we are everybody talking about OGI cameras or point monitoring. What I'm talking about is an holistic approach that you will have a fence line monitoring together with real-time point monitors in your facility. That's the way to find the problem. In 2015, the federal accepted the benzene rule that says every refinery must measure benzene on the fence line. I got a lot to say about this rule, if it's really protect the public or not. I will let the EIP, Environmental Integrity Project, to say what they have to say about it. But the results is like that. That in 2020, 13 refineries was exceeding the benzene rule, and 7 out of those 13 refineries do it 2 years in a row, meaning 2019 and 2020 still are exceeding. Why didn't they fix the problem? So this is how it's done. This is to read this report. Give you a lot of ideas, but what they say is true. Actual benzene levels are much higher than the network situation reported. The federal talk about 9 microgram difference, so we can have 1,000 and 1,008, and it will be in compliance. 1,000 ppb of benzene will still be in compliance, as long as your other point is 1,008 and not 1,003. So talking about delta, it's not good for the public. We want our technology definitely can be. Short-term benzene concentration may threaten the public health, and they are true. If you do 2 weeks average with the passive sorbent tube, you can have peaks of 10 ppm, and it will be noticed because you average for 2 weeks. And it can be a problematic also for the refinery and also for the public, and you must know it before. And people start telling, why just benzene? Benzene is maybe less than 1% of what's going out of the refinery. It's even not the most dangerous compound in the refinery. So why everybody got into benzene? It was everybody was speaking benzene, but there are other compounds like formaldehyde, the acrolein, that are in the same danger. And actually, we can measure all of them with the same technology, no added money. So if you put an open pass FTIR, you can measure all the compounds. You don't need to add a lot of money. Those actually also, if you do it with the passive solvent tube. they can measure, I don't know, 70 compounds. So why just ask for the benzene? And so they say that you should add more component to it. And why they are not fixing it? Because if you got average, how you know where the emission comes from? If you got real-time data and you can do back triangulation, and then where is the source? Now you can fix. Actually, the benzene rule allows you to use an open pass instrument, but they say you now must have a detection limit of 0.9 microgram per cubic. But what they didn't say is what is the time resolution. So I did a little math calculation. And if you take the passive solver, so for 1 hour, the detection limit will be 248 micrograms. And they will really be down in 1 microgram just after 2 weeks. But if I do the same calculation with an hour at least open path FTIR, accredited as 1725 accreditation, for 1 hour we got 1 ppb detection limit with the list, but let's say 1 hour, and for a day we 0.1, and for 2 weeks we are now in 0.012. So it's all dependent on time resolution, and when you say detection limit, it's also related to time resolution, and that maybe can help the refineries say, not that I recommend, that maybe I can move from passive solver tube into real-time measurement. I would recommend do them both. Not because I'm doing the passive solver tube, but because it's hard for you to miss the concentration or to miss the pressure. So a little comparison between point measurement and line measurement. Probability to detect the pollutant. So if you are in point, pollution must go to your point measurement, so it's low. If you are line, it's high. Expected concentration upon measurement. When you got the measurement, if you got the point measurement, it would usually be much higher than the line because the line will dilute it. Our representative of the olfactory, so 1 point is poor and 1 line is better. And sampling interferences, you got a lot of interferences, but if you know how to run your instrumentation, you can see all the interferences and you can subtract them. But when you do a point measurement, we created what we say the Fenceline system that monitor 24/7, tell you when emission starts, what is the emission, not just benzene, all the compounds, and also on real-time basis where it's coming from, and also quantification how much it's your need. A little bit how it looks like. So here we got an open path FTIR. It could be also UV dose. We shine on beam of infrared light if it's FTIR. If it's UV dose, we shine on beam of UV into a retroreflector. The energy bends back. In the way it reacts with molecule, each molecule absorbs lights in different region, and then we use the Lambert law to give concentration. Each system can cover up to 1 kilometer of a fence, so up to 1 mile of a fence. So do your calculation for your facility. The small facilities, 2 systems will be sufficient. If you are a big one, do your math. And this configuration called monostatic configuration, again, patent of Robert again. Problem starts because we can measure all the compounds with 1 instrument. Because we can do it, if you don't do it correctly, then you will have a lot of false positive and a lot of false negative. If you will not take all the interferences into account, then you will have a lot of false positive and a lot of false negative. And if you will not know how to do the analysis correctly, then you will have it. So you must know how to do it. At least, as far as I know, every number that we report, each one of our time can click on the number. It will open the spectral validation. Red is reference spectrum from NIST. Blue is what we're measuring in the field. And now you can be positive that what we reported, it's true. Sometimes people claim that we don't show what we do. So actually we're the only one that give our client the ground truth against NIST. And this is actually, if we compare something to NIST, it's called calibration. So each measurement is a calibration. You don't need to calibrate it because each time we compare our spectrum against this spectrum. So if you compare something against this, that's called calibration. So you don't need to calibrate it. You can do a verification, but not calibration. I love the FTIR because you got written methods. So you got US EPA method Tier 16 that allows you to measure any gases in the atmosphere using this method. You got ASTM, and instead you got quality procedures. How we do the source location, same as the previous presentation, but we do it on real-time basis. Get regulate the wind, find high concentration on that segment of the fence line. That the wind change a little bit, we find high concentration, different segment. That will give you the origin. So it's not that easy because you got multiple sources. You need to know how to separate them. And it will not be so accurate the first time. But imagine we've got thousands of those points. And now we can run a statistical algorithm to see where is the origin. For sure, we can tell you if it's coming from your facility or from the Dominguez channel or from a sulfur plant nearby, and we can do it on real-time basis. And because we want it to be easy to understand and to digest, and we know the operation are not PhDs, and we want them to run it so they will have this our screen look for our client, not to the public. And the brighter the color, the highest possibility that the leak is coming from that facility. And now you can send your other team with the sniffer, with the OGA camera, with the ultrasonic, whatever you want, and they will fix. So California on 2017 wrote the Assembly Bill 1647, and it says every refinery must measure the pollutant on the fence line and report to the public on real-time basis, no later than 10 minutes. Every refinery, that was the rule. All the refinery under this rule was supposed to put the resume operation on January 2020, and actually most of them did. Each one of the districts reached its own guidelines. And the guidelines were different. They decided that small refineries doesn't need to measure. What is small refineries? They decided 40 barrels per day, 40,000 barrels per day. Why? That's what they decided. Each refinery and each guidelines give a different list of compounds that they want to measure. And different time resolution, different quality assurance, a lot of fun. All of a sudden, from $0 market, and I'm very modest, created market about $50 million market with all those installations, with recurring revenue of around $50 million. Just by the rule, the industry did it like, I don't know, very good job, no complaints, everybody did it on the time. And if there is regulation, everybody obeys. That really did it. All the compounds were found, and what we found out in California, and I can tell you this is not the situation if you go to Canada. I'm not sure if it's the situation here in Texas, but more than 99% of the time, as you saw, everything is below the threshold. Sometimes we've got exceedances. Most of the time it's not related to the refinery. Sometimes it's related and they fix it. But we report millions of data points to the public. How we know that it's true or not? I cannot put our PhDs, or not spectrum PhD, to analyze each one of the data. We must have a software that will do it automatically. Otherwise, we will report bullshit to the public. That's why. So for our client, we've got a website for yourself that you got all the bells and whistles, source location, spectral validation, a lot of other features. And for the public, you got something that says green, it's everything, it's okay. And how this installation looks like. Maybe if you will have time later on, I will show you if you got that question. So this is the list of compounds, and this is our detection limit. These are the threshold by OEA, the Environmental Protection Agency of California or something like that. And this is the MPL from all the refineries from the quarterly reports. So this is for the South Coast, I think, or from all of them. And so you see quite a difference. Let's say one feel good at the end, we report around 0.3 ppb, and one can report 1.9 ppb. But if you go to Aqualand, then it's very dangerous. A rarely found compound because they don't manufacture it. It's a side product maybe, and the threshold is 1.1. So we can measure it in 0.3, but some of the other refineries claim that the detection limit is 30 ppb. The threshold is 1.1, and the detection limit is 30 ppb. Unrealistic, and it goes like that for at least 3 years now. But what we can see in this table that of the compound can be measured below the threshold. So if it can be done, everybody should do it. There's a big difference between the reported MDL. Each one of us do it in a different way a little bit. Some of them do it empirically, some do it measurement, some of them stop the measurement and do it once a quarter. Some of them measurement routinely. There's no distinguished rule how to do it. Actually, field MDLs and also our field MDLs were higher than what we thought in the beginning. And what we found out is in our installation that UV DOS didn't give a better detection limit for benzene. Yeah, the signal is much stronger, but the noise is also. This is from our installation, and we used for that installation Swedish UV DOS. Called OPSIS, accredited, got TÜV approval, all the approval, all whatever. And if you get the report, they should be in 0.2 ppb detection limit. But this is the actual measurement that we found. There are 2, sometimes 5 ppb. And they got TÜV approval of 0.2. So if I took the instrument and put it in the laboratory on optical chain, it will give me 0.2. But out in the field, when you got oxygen and ozone, then it started to change. And if you look at all over the data, with all the passes, you can definitely see that most of the time FTIR got better results, or real-time results. So you don't need to have an FTIR and a UV DOS FTIR, or good FTIR. I will not tell where it is, but there's a lot of others. So we're talking about Aqualand. If you get to read the quarterly report of that refinery, it says that his detection limit is 4. If you go into his website, then you got this, 0.6. Same refinery report on real-time basis, an order of magnitude different than what he reported in the quarterly reports, and there's a lot of problems going on. Then different site, then Aqualand 30 ppb, benzene with UV DOS 1.5, and sometimes they give results of 0 detection limit. A lot of problems with the quality assurance. In the beginning, there was a lot of alerts, not with Spectrum, but other refineries give a lot of alerts, and they were false positive. For example, concentration of 260 ppb of acetaldehyde or 600 ppb of formaldehyde, you cannot never see in planet Earth those concentrations, not in China, not in LA on the 50s. So they didn't do the analysis correctly, and the quality assurance was bad because they don't have spectral validation, and they reported to the public. Actually, 3 years later, they're still on the quarterly report, those incorrect concentration. For sure, it's bad for the company, it's risk of legislation, and you go find problems that do not exist. So Buying the instrument itself, it's not enough. You must have a person or software that knows how to do the analysis correctly. And as I said, each number that we report gives spectral validation. We talk about the Dominguez channel. In the beginning, there was no Dominguez channel, but there was also the first day we start operation, we had the threshold exceeding the H2S. I look at the wind and it was coming from the north. So I can tell my client that it's not his refinery. And then I decided to do back triangulation from all the refineries. And what I find out, that if I take all the data from all the refinery, I can say that the source is somewhere in between. Then I open Google Map, and I saw the yellow. Yellow is sulfur. So, meaning that if we wouldn't have this technology, everybody will blame the refineries, while there is a sulfur plant over in the middle that gives the high concentration of H2S. So this is from my last year presentation, and we found a lot of things that should be improved. That first of all the refinery had more than 90% completeness of the data. That we should improve the quality assurance and spectral validation of real time. Detection limit should be below OEA threshold, and OEA should be the threshold, etc. Most of the VOC emission from the refinery are okay. Not benzene, not BTEX, not formaldehyde. They're okay, like Exxon, and usually it will be mainly Exxon, butan, and things like that, and not benzene. So saying that the benzene is a cursor for the VOC emission for refinery is bullshitting the people. It's less than 1% of the emission. Yes, it's a dangerous compound, but it's not the main one. And if you want to find your leaks, if you want to improve your facility, go measure your alkanes. That is more easy and more representative. Benzene rarely found. In the last 3 years, we find one occasion of benzene. I think most of the refinery maybe had 1 or 2, not more. We're talking about 1,000 days of measurement, so we're talking less than a promille of the time. This is California. We can also measure greenhouse gases without additional cost. FTIR is very easy to measure greenhouse gases. And there's a lot of other sources near the refineries. And if you got meteorological data, you can say, like in the presentation before me, this is coming from the refinery. Lesson learned, one website. We said to the South Coast, you should have one website that takes all the data, give the quality assurance, and fuse the data from all over the refinery to give you a good data. 8 sites, programs and what we said that the program should go to terminals, few terminals, other chemical complex. Everybody take refineries, but actually there are more dangerous chemical plants or petrochemical plants like that manufacture ethylene oxide and things like that. All the product goes through terminals, and no one checked those terminals. So we should do that as well. But refineries are easy targets, so we started with them. When it's possible, we recommend follow USCPA method, and for FTIR, we got USCPA method. And there should be specific instruction how to do or how to measure detection limit. South Coast understand that there is a problem, and then they issued an RFP, request for proposal or whatever, to audit the Fenceline program. And They had a good budget into it. I think $1 or $2 million for auditing. It's quite a good budget. A lot of people try to go, but it started on mine, and the selection should be decided on August 2022. But until today, no one has been chosen. So we've got the budget. We've got people that want to do the job, but I don't know what's happening there. Next week in California, we push it. You know something you knew about it or nothing? Huh?
You don't want to do that audit?
They say that I got the conflict of interest.
Yeah.
So, but if you will let me do it, so maybe they will.
How about we audit everybody else, but I'll audit you and you audit.
That's good. That's what we actually do. So Colorado joined the party, and Colorado heard something about Fenceline monitoring, and they decided that let's do Fenceline monitoring. But they wrote a stupid regulation. They say you must measure just benzene, H2S, and benzene, H2S, and HF, I think, and you should measure refineries, but also terminals, and also coating something industry. Okay. If I don't even the terminal H2S, why should I measure H2S? And if I don't have HF in my terminal, why should I measure it? And in my coating facility, if I don't have benzene, why should I measure it? And why just measure for benzene in the refinery while their benzene is less than 1%, and we've got more than 20%, more than 20 other compounds that we should measure. So the green people raise their hand and they say, this is stupid, and we want you to measure everything, and it will not cost the refinery more, so let's measure it. So the government decided, let's add compounds. Then the industry go back and says, you cannot change our program now. So everything is in court, and I think last that I heard, it didn't start it. There's still negotiation. You are more inside the details, but as far as I know, it didn't start. Or it started?
There was a Fenceline monitoring program right now at some.
But the debate between the government and the litigation ongoing. Okay. So in the end, it's not 100% clear what should be and shouldn't be. And there are two, the Sancor claims one thing, the government claims something different, and the public claims something different. Okay. Just from January, end of January this year, there was a public meeting at the South Coast, and they said that the Greek people took them into the Supreme Court of California, them, and also San Joaquin, and also changes in the Bay Area. And eventually the changes says, you are as a district are not entitled to say what is a refinery. It's not just oil refinery, it could be also asphalt refinery, it could be other refinery. You are not entitled to say just measure BTEX. You must measure all what was said in OEA, all the compound that should be measured. And then all of a sudden, this is at least for the South Coast, there's the petroleum refinery, but also asphalt they want to add it, and also lubricated petroleum. So if we started from 7, now they're talking about adding those 7 in the near future. Not just that, also adding point monitors in the community. They will get more budget into it, $5 million per year for monitoring the ambient air over there. And they want to add a list of compounds. I can debate if it's needed or not, but this is what it says. Like add naphthalene that we can maybe easily add to our instrumentation, but how can we measure metals, cadmium on real time, and why should we? And then we can do it. There's instrumentation that can always do it, but It will cost the industry quite a lot of money. What we do is polyaromatic and sulfur and acid. So there's a lot of debate going on in California and here also. So the existing refineries will need to add more compounds into their monitoring. We'll need to have more uniformity in the quality assurance and things like that, and eventually will be audited. And new facilities will also be added for monitoring. This is in the South Coast, same goes with San Joaquin, and same goes with the Bay Area. We're talking about a different approach of Fenceline monitoring, and it's how we can measure greenhouse gases. And the difficult about it is, the methane concentration is around 2 ppm now these days. And if you are measuring the emission of methane, you are not near the source, very near the source, you're talking about concentration of 10 to 100 ppb. So how can we say what is the difference between the ambient level and the concentration? So there's a way how to do it, and we know how to do it, and we done it in the oil sands, measuring ponds. Now, how much is the emission of the greenhouse gases from refinery or from the operation? It can be done with Fenceline monitoring. And for the first time, there was repeated the concentration year after year that says the same. Before that, they would do it with floating chambers and things like that. And every time they got orders of magnitude difference between each year. So there's a way to do it correctly today. And this is a project of 2015 we did for the South Coast. First time we found the leak, one tank that was leaking was releasing VOCs in the order of 300 kilogram per hour. Because we found it, you can shut it down, fix the problem in 6 hours, and don't wait while here one holding that emission. Now we're doing a project of Fenceline monitoring for ethylene oxide in this area somewhere. Ethylene oxide is very dangerous compound, much more dangerous than the benzene. Flammable. And the EPA says that the threshold should be 0.001. No one can measure it, but we can measure around 1 ppb. This is from Louisiana. And this is another survey. When you are near the source, concentration can be around 10 to 100 ppb of ethylene oxide. And there's a lot of money into it. The last legislation in the United States gave penalty of $360 million for emission of ethylene oxide. So keep in mind, if you run an operation, it's better to know what's going on than to go out bankrupt. Again, ethylene oxide, this is how we are measuring. This is in 1 ppb detection unit, and the higher concentration goes, can measure it with better fitting. Again, ChatGPT, and I asked if we can measure the PFAS. It's everybody talking about PFAS these days. And ChatGPT says, yes, you can measure it with OpenPass FTIR. Okay, so ask him a little bit more about the science, where should I look, what bands, etc. And again, it gave me, you should look at that band and that band. And then I went and opened my chemistry book, then I did the simulation. So PFAS can be measured with OpenPass FTIR. A different question if you find it in the ambient air or just in the water. This is a different question, but if it will be in the gaseous phase, definitely we can measure this. So in conclusion, what's new in the Fenceline measurement? The requirements for Fenceline measurement, petrochemical industry are moving forward. New legislation in California. We're talking about Colorado. I don't know what about the CQ, if you're still thinking about it or not. Louisiana thinking about it. It's going to other chemicals, not just benzene. We're talking about ethylene, ethylene oxide, and other compounds. The size of the refinery is not relevant for the requirement. You can have small operation that emit more than a big operation. Colorado joined the program, but the program should be tuned. Terminal should be monitored and other compounds.
Well, thank you very much, Gilad. That was excellent way, I think, to summarize our session. I want to make sure that we get everybody signed up. Sign up sheet. Questions?
Excellent question.
If the lessons learned from California indicated that benzene was less than 1% from refineries, what was it for alkanes again? What was the estimated number for alkanes based on the data that we have so far?
Alkanes are usually around 70% of emission from refinery. BTX, if you sum all the BTX, is around 5%. Benzene is less than 1%. And you can go into the website of each one of us, read, usually you will find total alkanes or total VOC. This is not the difference. Some of the Fenceline don't report nothing, so there are no VOC going out of refineries. But if you go to the ones that knows, and at least there are two over here, you can see that most of the time you will have total alkane, and rarely you will have BTX. Okay. Enjoy your lunch.
Thank you.
Yeah, good. Thank you.
Ain't no crazy that one. Yeah, the thing is, we like what we do, so I stop, and I mean, physically, I have to slow down. I have to really. Yeah. I appreciate
Yeah, I put minus in the
Yeah, that's right. Adding more. I was gonna be, I don't deal. You're very constant on it.
Yeah, and definitely existing facility. Yeah, let's say you got time, I don't know. Something like that.
Yeah, same, yeah, so what we do.
So that's really now, I got a version of access
Yeah,
that we integrated, so we integrate the data from your GCs together with Fenceline.
yeah, so whatever we do.
If I got the opportunity.
So I'll point some.
Thank you.
All right.